All right, let's take a look at our lesson on graphing polynomials. There are a lot of guidelines that we have available to us to help us graph. One of our focuses is, what does the end behavior look like? Does this polynomial, start down, start up? What does it do? And to give us some information on that, we would look at the degree. Let's focus on the degree being odd first. Remember, the degree, what we have looked at before, is the highest exponent if the equation's in standard form. So if the degree is odd and the leading coefficient, these vocabulary words, y'all getting these vocab words? The leading coefficient, remember, that's the number in front of the variable with the greatest exponent, the largest exponent. So if the degree is odd and the leading coefficient is positive, what will happen is we will start down. So see how we're starting down and we end up. So if the degree is odd, the end behavior is different. Okay, and the end behavior is different if the degree is odd. So we've established that degree is odd, end behavior is different. And what the end behavior does depends on the sign of the leading coefficient. So if the leading coefficient is positive, then our polynomial will start down and end up. If our leading coefficient, on the other hand, is negative, then we will start up and end down. Okay, so we can do little arrows if you want. We can start up and end down for odd negative. For odd positive, we would start down and end up. Now you might remember from previous lessons this notation: as x goes to negative infinity, f of x or y goes to negative infinity. That's describing this end behavior. As x goes to positive infinity, so x is heading towards the positive numbers, y or f of x is heading towards positive numbers. So those are descriptors of the end behavior. Just recall f of x is y. All right, so that is what we're looking at with odd degrees. Now let's take a look at, well, what happens if the degrees are even? What do we do then? What happens with even degrees? So let's look at even degrees. Okay, so if the degree is even, the degree is even, that has a different scenario. If the degree is even, the end behavior is the same. And if the leading coefficient is positive, then what happens is we start up and end up. So we start up and we end up. Okay, that's if it's even positive. Okay, well, let's look at the other scenario. What if it's even, the leading coefficient is negative? Then what do we do? Well, we start down and end down. So we start down and end down. All right, so that's an overview of how we determine end behavior, and just a reminder of these kinds of notation that we'll be using to describe the end behavior. Now let's explore one thing just quick before we go on to some examples, and let's remind ourselves, well, how do we know? Let's look at some examples. How do we know if the degree is odd or even? How does that even look? So let's look at, first of all, there's two different forms that you may find the function in. There's a standard form, and we read standard form differently than factored form. we're going to look at both of those options. We have standard form and factored form. Okay, so I'll give you an example of standard form. Let's see, it's 3x to the fourth plus 2x. Okay, that's standard form. We start with the highest exponent and then decrease down. So you can see that this is the largest exponent, and this is a fourth degree polynomial. 4 is an even number, right? So this is even. Even numbers, 2, 4, 6, 8, etc. So this would be a fourth degree even, and my leading coefficient is positive. So even positive would reflect, this would look like this scenario down here at the bottom, even positive. Well, that's if the equation is in standard form. What if it's in factored form? Now we read that differently, and this is something that can be very confusing to students. We read factored form degree very differently than standard form. Standard form is easy. You just put the terms in descending order and you pick the biggest exponent. That's not a big deal. If we're in factored form, it's different. We don't do the same thing because we're not in standard form. So let's look at this example. Let's say x to the first times x plus 2 squared times x minus 3 cubed times x plus 5 to the first. Okay, let's say we're in factored form. Well, how do we tell the degree when we're in factored form? That seems confusing. I really don't want to multiply all that out. That would be very time intensive. So we do have a different way that we can decide our degree and leave the equation in factored form, or the function in factored form. What we do is we look at all of these exponents. See, the factors, so remember these things are called factors. I have called them bubbles before. These things are factors. The exponent that the factor is raised to. And then we take those numbers and we add those up. 1 plus 2 plus 3 plus 1. So that's 7. So this is a 7th degree polynomial. This is a 7th degree. So this one is odd, right? This is odd. And so odd would be like, 1, 3, 5, 7, etc. Those would be odd. And now how would we figure out the leading coefficient? That's really confusing. Well, we would look at the coefficients of all of the x's. We would just look at them. Typically, they're all going to be 1. Normally. So then my leading coefficient, in this case, it's positive. This x is a positive. There's nothing in front of it. It's not negative. So therefore, this would have a leading coefficient of 1. And so that would be positive. This would be a 7th degree positive. So 7th degree is odd, and the leading coefficient is positive, so it would match this scenario. All right, so hopefully that gives us some good background before we jump into our examples. Okay, so let's look at the first examples. And what this wants us to do is simply describe end behavior. That's it. We're just looking at end behavior. Okay, we can do this. And we basically complete these statements. Okay, we're going to fill it. And we've done this before, so hopefully this isn't too bad. We know it's going to be as x goes to negative infinity, f of x goes to, I'm going to have to put something there. As x goes to infinity, f of x goes to. Okay, so let's investigate this. This one, so it's in standard form. This is even. And my leading coefficient, I'll just abbreviate leading coefficient for LC. Leading coefficient is positive. Okay, even positive. Okay, let's remind ourselves, this is something there's no way to get around this. Sorry guys, you're going to have to memorize it. Even positive, the end behavior, so even, the end behavior is the same. If it's positive, we start up and end up. So basically, we're going to, as we head to negative infinity, we're going up to very high y values. As we head to positive infinity, we're going up. So both of these directions would be the y is going to get bigger and bigger on both scenarios. Okay, let's do the next one. So again, this is just a template. As x goes to negative infinity, f of x or y goes somewhere. As x goes to positive infinity, f of x goes to somewhere. Now let's investigate this one. All right, so this this is basically this degree is the 5th degree. So this is odd. This is odd. And the leading coefficient in this case is negative. Okay, so leading coefficient is negative. Okay, so we've got odd, negative. Okay, odd, negative. Let's go back and refer to here. So odd, negative starts up and ends down. So as x goes to negative infinity, y goes to infinity. And as x goes to infinity, y goes to negative infinity. All right. Now, before we start sketching, I do have some, you're like, no, there's no more guidelines. Sorry, there are a few more guidelines we have to go through. I guess there's a lot going on with sketching polynomials. We're going to go over here to the side, and we're going to look at some information that will help us as before we start this next piece where we're graphing. So what we want to do is when we start graphing, so we need to notice some things. We need to, number one, we need to look for and find the degree. We need the degree of the function. You guys know I love steps, so I want to write out steps. So we need to find the degree of the function. We also need to find the sign of the leading coefficient. Okay, we need to do those two things. Okay, perfect. Then we need our equation, it needs to be factored. And mostly they already are. It's not something that you would need to do. Mostly they already are. And what you do with the factors, it needs to be factored, and you're going to be looking for the degree of each factor. Why would you do that? Well, the degree of each factor determines the shape of the polynomial at that location. For example, I'm going to give you some examples. If we have a first degree, okay, we have a first degree factor. For example, let's say we have x plus 2 to the first. Okay, so we would have this graph. Our 0, if you remember, now remember the 0 or the solution or the x-intercept, they have so many names, is what would make the factor 0, right? What plus 2 would equal 0? Well, that would be a negative 2. Now, when the factors to the first degree, the appearance of the polynomial will be what we call a cut through. It's just going to be like it'll go straight through. So the word that we use for this shape is cut through. Okay, so that's what happens if your factor is first degree. If you have a second degree factor, I'll give you an example of that. Let's say x plus 2 squared. Okay, let's look at that. So again, we know that the 0 or solution is what makes that, x plus 2 0, which is negative 2. When we have our second degree, our factors raised to the second degree are basically an even degree, second degree or fourth degree or sixth degree. We're going to have something called a bounce. This is called a bounce. And so this would be an example. Okay, it's going to bounce off of that spot, the negative 2 spot. It could bounce off, it just depends on which way you're coming from, whether you're coming from above or below, but it's going to bounce. And so it would bounce right off of that spot. Okay? So the third scenario, let's say we have a third degree. An example of that would be, say, x plus 2 cubed. Okay, this one is called flatten. So what happens is, I don't know if you recall what x cubed looks like when it's graphed. It's kind of flat at the 0. So we're going to go over here at -2 again, and so what happens, it comes in, it kind of flattens out, and then it goes. It just kind of flattens out. Let me see if I can draw that better. So it comes in and flattens out. Okay, so that's going to help us. This information right here is going to help us as we start to look at graphing these next problems. It's going to let us know which way, what is the polynomial supposed to look like as it travels through the x-axis. What's it supposed to look like? And these are our guidelines. Okay, great. So here we go. Let's try this out. Now, when we're sketching, we need to actually sketch from left to right. Okay, so this is kind of important. We need to sketch from left to right. Okay. So let's look at our guidelines. So we need to see the degree of the function, the sign of the leading coefficient. Okay, so let's look at the degree. So remember, this is factored, so we're going to have to add this up. So 2 plus 1 plus 3. So that's 6. Okay, so this is even, and my leading coefficient is right here is positive. So my leading coefficient is positive. So I have even positive. Even positive starts up and ends up. Okay, these are things that we just really have to know. Okay, so it's positive, it's even, it's going to start up and end up. Okay, so let's draw our coordinate plane. And we need to graph the zeros. So let's, we've got the first factor, x minus 3, gives us a 0 of 3. So we're going to graph it. X plus 1 gives us a 0 of -1. And x plus 5 gives us a 0 of -5. So 1, 2, 3, 4, 5. Okay, here we go. Now, I hope you are going to be able to see why this is so important, that we have to start up and we have to go from left to right. So I'm going to be up here. And as I head towards my first 0, the 5, I see that it's got a 3. So I've got to flatten through there. All right, so we're going to flatten through there. Okay, so that's the behavior at the x-axis. Okay, so as I keep moving from left to right, I need to go through the 1. Let's see what this -1, excuse me, has a factor of 1. So this is a cut through. So I'm just going to come up and cut through. Now it doesn't really matter. It doesn't really matter how low down you go. You can go down as low as you want to, or just shallow. It doesn't matter. We're not really worried about that right now. What we are worried about is the end behavior, and the behavior, what the polynomial looks like as it goes through the x-axis. Okay, so our last 0 is at 3, and that is squared. So that's supposed to be a bounce. So we're going to come down and we're going to bounce off and come up. And I need to, okay, so we need to make sure that the line that we draw, the curve that we draw, is curved and not pointy. Great, yay, we just did our first one. Woo! Okay, let's do one more. All right, so let's investigate this. All right, so I have, this is to the first power and third. So let's add all those up. So I have 1 plus 3 plus 2 plus 2. So what does that give me? That gives me 8. So I have an 8th degree, and my leading coefficient is negative. Okay, so I have even, negative. Okay, even, negative starts down and ends down. Okay, we can do that. All right, so let's draw our graph. Let's see, we've got this x on here, it gives me a 0 of 0. X minus 4 gives me a 0 of 4. X plus 2 gives me a 0 of negative 2. And x plus 5 gives me a 0 of 1, 2, 3, 4, negative 5. Okay, we need to have our zeros plotted. Okay, so now we've got to see what's going on. I got to start down, so I'm going to start underneath. Let's see what happens at the negative 5. See how this is squared? So I'm going to have to come up, and I'm going to have to bounce off the negative 5. All right, now let's see what happens at the negative 2. Oh, it's another bounce. Oh, it's a crazy one. All right, we're going to come up, and we're going to bounce off that 2. All right, at 0, that's 1, so that's a cut through, so I'm just going to come straight through. And at 4, that's cube, so that's flatten. So I have to come down and flatten. Oh, that looks terrible. So flatten, to me, the flattened ones are hard for me. So that's kind of flat. Okay, great. Let's take a look at our second page. See what we got going on over here. Just some extensions of what we're doing. Okay, so now they're giving us words and they want us to figure this out. So write an equation in Sketch. So we have a single root at 5. Okay, so let's see, a single root at 5, that would look like x minus 5 to the first. It's a single root. Okay. We have a triple root at negative 2. That would be x plus 2, and that would be tripled. We have a single root at 0. That means just a plain old x, and it's a single root, so to the first. Oh, our leading coefficient is negative, so I need to stick a negative there. All right, so let's investigate what's happening for all of these. So this to the first would be a cut through. This would be a cut through. This would be flat. Okay, so that's what's going to happen to the polynomial as it travels through the x-axis at those 3 locations. Okay, so let's see what else we need to know. We need to know the degree. So 3, 4, 5. So this is a 5th degree. How did I do that? Well, I just added up those exponents. 3 plus 1 plus 1. 3 plus 1 plus 1 gives me 5. Okay. And my leading coefficient is negative. Okay, so I have odd, negative. Odd, negative. It's going to start up and end down. That's what it's going to do. Start up, end down. Okay, we can do this. We got this. All right, so we have 0, 1, 2, 3, 4, 5. We got 5. We got negative 2. Okay, it's going to start up. We're going to start up. So at 2, it's a flat, so I need to come through here kind of flat. At 0, it's a cut through, so we're going to come through. And at 5, it's a cut through, so we're just going to go straight through. Yay, we did it. Okay, a couple more problems. These are just a little, we're just extending what we just did, just a little bit. From the graph, from the picture, what they want us to do is to write the equation for it. Well, we see the zeros. Now, what we need to pay attention to, we're going to have to deal with this. We'll deal with that in just a moment. If they give us a point on there, we have to do something a little bit differently. So let's look at what that would be. So we would have to say y equals, and a, we're going to find a by using this point in a moment. It's going to take us a while, but we're going to find a. So then let's look at our zeros right here. So that's a 0 at negative 3, so I know it's x plus 3. It is a bounce So I know that's x plus 3 squared. Okay, I have another 0 over here. That 0 is at 0. So that's just x. And it's flattened, so that's x cubed. And so then I have another 0 right here at 6. That would be x minus 6. And it's just a cut through, so that would be to the first. Okay, so that's what we have going on. It's great. What would we need to do? So we need to find a. How are we going to do that? Well, we're going to take the point that they gave us. This would be my x and that would be my y, and we're going to plug that in and just solve for a. So I have 2 equals a times x is negative 2, so negative 2 plus 3 squared times negative 2 cubed times negative 2 minus 6 to the first. Okay, let's do our arithmetic. Yay. Let's see, negative 2 plus 3 is 1. 1 squared. Negative 2 times negative 2 times negative 2 is what? A negative 8. And then I have a negative 8 to the first. Okay, so let's keep cleaning that up. So 1 squared is just 1. So negative 8 times negative 8 is a positive 64. So a is going to be 2 over 64. Or let's simplify that fraction. That's what? 1 over 32. Okay, great. So let's write our final answer. So y would be 1 over 32. And you usually would write this single, like when the our 0 is 0, you would normally write that first. You don't have to. That's just what you would normally do. Whoops, goes down here. So x cubed, and then it doesn't really matter the order you write the other ones in. X plus 3 squared, x minus 6. Whew, okay, looking good. So one more, same scenario. We're given a point. So since we have this point, we have no choice but to do the a thing. Okay, we got this, guys. Let's go. So we've got y equals a. Okay, so let's look at this 0. This 0 would be x plus 2, and that is a cut through, so that's a 3. Then we have at 1, that's x minus 1, and that's to the first. And we have another 0 at 3, so x minus 3 to the first. Okay, so now let's use that point, 0, negative 4. So negative 4 equals a times 0 plus 2 cubed times 0 minus 1 to the first times 0 minus 3 to the first. Okay, let's look at our arithmetic. So 2 times 2 times 2 is 8 times negative 1 times negative 3. Okay, let's see, what is that? 8. Negative times negative is positive. 8 times 3 is 24. So a would be negative 4 over 24. And we simplify that. We get what? Negative 1/6. Okay, let's write our polynomial. Y equals negative 1/6 times x plus 2 cubed times x minus 1 times x minus 3. Yay! Okay.